Good day everyone. This video is for our project group assignment DMFT 2433 Instrumentation and Control. The title of our project is Installation of Magnetic Float Level Switch Sensor at Culvert Pump. The problem background. Sarah has installed an electrical pump in the culvert. This is because on rainy days the culvert will be filled with water and sometimes the water will overflow onto the roads. As we know, a pump produces liquid movement or flow. It produces the flow necessary for the development of pressure, which is a function of resistance to fluid flow in the system. The issue is, after the rain, the water in the culvert is removed by the pump, also through evaporation, leaving the culvert empty. However, despite the dry condition, the pump in the culvert is still running. The pump has to be manually off in order to stop operating. The lifespan of the pump will be shorter than expected. This is because a pump running in dry condition will cause failure to the pump in a certain period of time. Also, replacement of such pumps in culverts are costly. Our task is to install a replacement sensor to overcome the level sensor problem in the culvert. Sensor requirements and suggestions includes on and off automatically, less maintenance, low cost, water resistance, and suitable for outdoors. Our group suggestion includes sensor position, sensitivity, range and span, accuracy and non-linearity error, and also some resolutions. Thank you.
Saya Sabila binti Muhammad Taha. I am now presenting predictive maintenance of magnetic level sensor for culvert system. Predictive maintenance is a process which alerts a maintenance technician to a problem that develops in a critical production system. This strategy offers cost savings over regular or time-based preventive maintenance, since activities will only be undertaken if necessary. It assesses the state of the equipment by regular or continuous using online platform monitoring of the state of the equipment. Many predictive maintenance are conducted as the machinery regularly works to avoid interruption of the regular operations. This technique is designed to help determine the condition of the equipment in service to estimate when maintenance should be carried out. The main promise of this activity is to allow convenient scheduling of corrective maintenance and to avoid unexpected failures of the equipment. In order to maintain the system, we must set the schedule to calibrate the system. The monitoring of the reading helps to detect the problem occurs early. Mounting and preventive maintenance are the recommended installation method for level gauge. Before installation of the level gauge, the mounting methods must be done correctly. Firstly, vessel nozzles should be checked for horizontal and vertical alignment. Secondly, vessel nozzles must be straight and even with no bends. Thirdly, center to center distance of gauge and vessel nozzles must match. And lastly, vessel and gauge nozzles should be free of sediment, dust, and rust. Periodic inspection will keep the level gauge operating properly for many years. This gauge provides level indication on critical services, and systematic program of preventative maintenance will provide excellent long-term protection. We must first keep the inside and outside level gauge clean. If there are any impurities in the process, or if it tends to build up on equipment, it will be necessary to flush the gauge periodically. How often or thoroughly will depend on the nature of the process liquid. It is important that the fluid can move freely inside the chamber. If there is an externally mounted transmitter or alarm switch, it is important that all covers and seals are in place and maintained. Moisture, dust, and debris entering these electronics housings can cause permanent damage, leading to failure. Monthly inspection for fluid, terminals and connections should be done. Take the fluid off the chamber once a month to test for leakage or damage. Replace and reinstall the fluid. Proper fluid is critical to level gauge operation. Lastly, check the electrical terminal connections and wiring for signs of damage due to heat or vibration. Excessive heat can cause wire insulation to become brittle and crack or fall off. Exposed wire can cause shorts or sparks, creating a dangerous situation. Excessive or constant vibration can cause terminal screws to loosen, creating intermittent or lost connection. Check that all electrical connections are tight and wires are flexible with no signs of heat damage. That's all from me. Thank you.
Assalamualaikum, my name is Nur Shahin binti Rospi. So here I'm gonna cover my part, which is the transient response of our sensor, which is flood level sensor. So we look at the graph. This is the system, the transient response of the system. So we see the graph. The blue one is the C1, the green is the C2, and the red line is C3. So this is an example of the related system sensor of our project. So we look at the red line, the C3. C3 is among the highest peak. We see the peak. The peak shows that the peak of C3 shows that C3 is the highest peak. So it shows around 0.2 to 0.5, around 0.35 second. So that is the peak value of C3. While in C2, the peak value is around 0.2 to 0.4 also. And then C1, it doesn't have the peak value because the rise value, it stopped until 0.4, and then the line will become constant. The response line will become constant until the end of the time. So as we mentioned, that float switch sensor is a device that detect the level of a liquid within a tank. So we can see in the tank the response. We can produce the code and then transfer to a response system to see the response from the equilibrium or steady state. Thank you.
Hi, my name is Ko Jingxian, and I will explain about stability. First, we need to know what is stability. A system is said to be stable if its output is under control. A stable system produces bounded output for a given bounded input. If the input is bounded but the output is unbounded, the system is unstable. In addition, if the input is unbounded, we will see an unbounded total response, and we cannot draw any conclusion about stability of the system. Physically, an unstable system whose natural response grows without bound can cause damage to the system. A stable system has transfer functions with poles only in the left half plane. Next, types of systems based on stability. There are three types. First one is absolutely stable system. System is stable for all the range of system component values. If all the poles of the transfer function present in left half plane, so this system is said to be absolutely stable system. Next, conditionally stable system. System is stable for a certain range of system component values. And the last one, marginally stable system. System is stable by producing an output signal with constant amplitude and constant frequency of oscillation for bounded output. If any two poles of the transfer function is present on the imaginary axis, so this system is said to be marginally stable system. So we need to know how to ensure stability of the system. Addition of poles to the transfer function has the effect of pulling the load locus to the right, making the system less stable. So addition of zeros to the transfer function has the effect of pulling the load locus to the left, making the system more stable. Thank you.
Okay, now the part that I'm going to explain is details. Okay, let's see the specifications first. The specification of magnetic float level switch sensor. Okay, the life expectancy of the sensor is minimum 1 per 10 power of 6. Allowable impact is maximum 100 meter per second square. Insulation resistance more than 100 mega ohm at 500 VDC for metallic sensor only. Withstand voltage 15,000 V for AC for 1 minute for metallic sensor only again. So I'm moving on to the next slide. Okay, when we see the next slide here, I have included the contact capacity, working current, and working voltage of the sensor here in a table form. Okay, here I have included a picture of the magnetic float level switch. There is stem here, reed switch, magnet, float, and stopper here. Okay, so next slide is the working principle here. Actually, to explain it very shortly, I have included here. This is the way to explain it very shortly. The float rides on the processed liquid surface, precisely tracking liquid surface motion. Rising liquid level lifts the float, sliding the attraction sleeve up inside the enclosing tube and into the magnetic field to actuate the electrical or pneumatic switch. This signals the presence of liquid. Falling liquid level lowers at the float, drawing the attraction sleeve of the magnetic field to deactivate the electrical or pneumatic switch. This signals the absence of liquid. So this is to very explain very shortly. I have included the full thing in the report. Then when it comes to the formula, okay, pressure is often used as an indirect method of measuring liquid levels. As we know, pressure increases as the depth increases in the fluid. So we can see here in the formula itself, change in pressure is equal to specific weight times with depth. Okay, the next slide. Okay, the buoyancy B or upward force on a body in a liquid can be calculated from the equation. What equation is that? Buoyancy is equal to specific weight times area times weight, the depth. Okay, this one is how to reduce steady state error in the system. So to achieve zero steady state error, the gain would have to approach infinity. Therefore, for first order system, a proportional controller cannot be used to eliminate the step response steady state error damping ratio. This shows that the steady state error can be reduced by increasing the gain. So that's all. I'm ending my presentation here. Thank you so much.